Good morning, good afternoon, and good evening, everyone. My name is Brian Foster. I'm a content director here at PingCAP, and I'll be your MC for today's event. Disaster recovery is a core feature of every enterprise-level database. Unfortunately, though, not all databases are created equal, especially when running workloads in the cloud. This can create confusion for organizations who need multi-region deployments to support their growing businesses. In today's webinar, we're delighted to have PingCAP Principal Project Manager Ben Meadowcroft, who will walk through the options for handling disaster recovery with TiDB. Ben has over 20 years of experience in the tech industry and has dedicated the last 12 years of it to product management in the areas of data protection, data management, and data security solutions. He's also previously worked at Rubrik, VMware, and AWS. Before we get started, please feel free to drop your questions directly in the chat window. We'll be sure to answer them during the Q&A portion at the end of the talk. And with that, I'd like to hand it over to Ben. Ben, the floor is yours.
Thanks, Brian. Appreciate it. And thanks for the intro. Yeah, I'm in product management here at PingCAP. So excited to be talking to you today about disaster recovery, particularly with TiDB and how we can really bring all that together to help deliver a solution with the availability and resiliency that you need. Okay, so first of all, talking about disasters. This wouldn't be a talk about DR if I didn't have a picture of a natural disaster. So here's one that I'll share with you. This is one, pretty recently. This was a storm called Storm Polly. So Storm Polly was actually an extratropical cyclone that kind of hit the Western Europe area last year in July 2023. And this is a good example of a disaster that I wanted to share because of the impact that it had, particularly on data centers and cloud services and so on. So actually, Storm Polly, when it hit, it actually had a really widespread impact, including impacting Microsoft Azure's Western Europe region. So this is a picture that Microsoft shared in their incident report of essentially, trees getting uprooted by the wind, and in this case, pulling up some of the cables along with it. And these were the cables that were the fiber links that were essentially connecting the different availability zones within the Western Europe region. And so, this had a huge impact on that connectivity between the different AZs, leading to congestive packet loss as these, some of these fiber links were cut, and whatever remaining capacity there was quickly overwhelmed. So this, as you can imagine, had a huge impact on customers who were deploying into this region. And the impact on this intra-region networking also had impact on downstream Azure services as well. What made this worse was that actually there was a previous incident that happened probably about a month or so before, and with the capacity augmentation that Microsoft were doing in this region, and it has some issues. And so this augmentation, adding new capacity to the region, they were taking it very cautiously as they were building out that capacity. And so when the storm hit, they actually hadn't built out the full capacity that they needed for the resiliency that they were aiming for, which meant that the impact of this was much larger than expected or would have been hoped for. So one of the recommendations that Microsoft shared with their customers at the time and during the incident was and this is a quote from their post-incident review. He said, "During the incident, we advised customers who were able to fail out of the West Europe region to consider doing so." So while the region still had some connectivity, particularly to the outside world, the issues with intra-AZ connectivity, were causing a huge issue. And for customers who were located there, who were able to fail out, that was a recommendation. So I thought I'd start off with this just to kind of show that, natural disasters do happen, they can impact us, and it's something that we need to be thinking about in terms of how we plan for responses to these kinds of events. So in this session today, there's really three things that I want to cover. The first is about understanding your risk exposure. What are the types of risks that you're exposed to? What do you need to be guarding against? And we'll talk a little bit more about that. Second, how then we take that understanding of the risk exposure we have and how we can then make sure we're designing for availability and recovery, that we're architecting the solutions and the systems that we're putting in place so that we are able to deliver the right level of availability and recoverability that we need for our applications and services. And then the third thing that I really want to talk about today is the importance of ongoing testing and validation and how critical that is to this whole endeavor. And I'll talk more about the importance of that and why it's so important. And then also I'll give a short demo of some of the capabilities of TiDB that enable you to test and validate your recovery. So with that, let's go on to talking about understanding your risk exposure. So risk exposure is really the combination of what I call like the impact of the risk or the impact of the incident and the probability of that incident occurring. So as you can imagine, there may be incidents that would be, very impactful, but quite unlikely. If you're located in certain regions of the world, the storm that we talked about, maybe you never get those kind of weather events, or it's very rare. It's a 1 in 50-year chance. It happens once every 50 years or so. So the impact may be very high, but the probability may be low. Or it may be something, depending on where you're located, you may be at very high probability of those kinds of risks. And so really understanding the types of risks that you're subject to, the impact that they would have on your business, both before any mitigation, and then we'll talk about during design how we can mitigate those and lower the impact. And then also understanding the probability of that all kind of boils up into this concept of risk exposure. And so for those of you who are familiar with this area, understanding things like business impact analysis and so on are key things that you would do to help better understand this area. So let's talk first of all about probability. So the probability of a risk occurring or an issue occurring can vary widely. And it can vary from kind of component level things, like it may be a server failure, component on the server, like CPU or storage or something like that, ranging to things that have probably a wider impact. So things like sustained power outages, cyber incidents, floods or fires that may affect you, storms and so on. So the probability of each of these is kind of independent in a lot of ways, but also you need to be aware that, for example, things like a server failure, may be relatively rare, but if you have a lot of servers, then the probability of an incident like that occurring increases. So a great way to think about this is if you're rolling, an example I always use is the concept of rolling some dice. If you roll a single die, you have like a 1 in 6 chance of hitting any particular number. But if you take, 100 die and roll that, the likelihood that you would roll a 6, say, is much higher within that whole set of dice. So as you increase the number of components, you're increasing the likelihood that you will have to deal with one of these kind of incidents. And this can range, as I mentioned, the scope of the incident may be larger or smaller, and that will play into the impact that we'll talk about next. So when we talk about impact, is of course understanding exactly what it's impacting. And this ties essentially back to the applications that we're running on that infrastructure that may be impacted. And so, of course, whether a server is up or down is fairly self-evident. Either it's available or it's not, or maybe it's impaired. But the thing that really matters is the application or the service that's running on top of that. And this is where things like your service level objectives come into play. So, the importance of those servers, of those clusters, and so on, really depends on the workloads that are running on top of it. And those workloads come along with the service level objectives that you're aiming to achieve, whether that's an availability SLO, latency SLOs, and throughput SLOs. All of these are objectives that you're attempting to meet, and that can be impacted by whatever risk you're dealing with. And so the risk exposure is really all about understanding the probability of an incident and how that would impact the service level that you're able to deliver and achieve. So that's a little bit about risk exposure. Now let's talk about designing for availability and recovery. So this is really the next step that we're building on. So we understand, the applications, the risks that we're looking to guard against and our exposure to those. And so then now when we look at, hey, how do we design our application, particular when we're thinking about databases like TiDB and the equivalent OLTP and OLAP databases, we're really interested in understanding, okay, well, how can we design them to be resilient and deliver the availability, latency, and throughput that I need to, and this is where understanding that comes into the design. So, very traditional application, very old school, may just run on a single server. So we have like a small application or a single server application that we just run on one server. That's great. While the server's up, we're serving serving our customers. I remember, quite a while ago, I worked for a very small startup company. I was, there was literally a handful of us working, and our first application was one that essentially we just ran on a single hosted server. It was incredibly, simple architecture and a simple deployment, but it does have risks. We talked about the risk of server failure. If a component on the server or the server goes down, we may have issues that we need to deal with. So the next step is really, okay, how do I cluster that application? How do I deploy something that's going to be resilient to server failure? And so this is where clustering comes in. And this generally will help you to be more resilient because you still have the likelihood of a server failure, and you've got 3 servers now that could potentially fail. But if you, with the distributed architecture or clustering it across these multiple servers, you're able to be resilient to the loss of a single one of these servers, say, and still continuing to serve the application needs and the availability SLO that you've defined. So now, this may be a set of servers all within a single cluster, say. But now, let's say we want to get more resilient to that. We want to be resilient to, say, cluster failure, rack failure, or if we're deploying into the public cloud, resilient to the failure of an individual availability zone. So this is where we then take the same concept and now begin stretching it over metro distances, over availability zones. And so again, this brings in, again, an additional level of availability, helps you to better meet your availability SLOs in the face of these broader scoped incidents that you may be looking at. So as we look back on the risk exposure, some of the risks that we may be wanting to guard against could have affected, say, an entire data center, an entire availability zone, or an entire rack. There's different levels we may be thinking of. And by now distributing across those components, or those broader sets of components across availability zones, across racks, we are able to better guard or better mitigate against those risks occurring and meet the SLO that we're shooting for. Now, as we start to expand our application across availability zones, or in the previous step across servers, once we get outside of that single server deployment and start doing inter-machine communication and machine communication across racks or across availability zones, we start seeing things like latency begin to be introduced. So going back to that earlier example, I worked for a startup. We had a single application that was running on a single server, and we wanted to evolve that to be more resilient to failure. And so we started to distribute it across different servers, started to cluster that application. And this introduces some new complexity, introduces some new latency. And so this was all things that we needed to understand as we were thinking about the service level objectives in terms of availability, but also in terms of latency and throughput, that as we start going over further distances for the communication, that there is some small latency impact that begins to be introduced. And as we get further and further apart, the latency can increase. So the next step, looking at, hey, how do I avoid issues not just with, say, a single region, like say in the example earlier, the Azure West, Europe West region, that was a region-wide impact. Well, I want to be able to now introduce intra-region or cross-region availability, perhaps going across continents and so on. And so this is where Then looking at the solutions that enable you to go over longer distances and move and copy the data into different locations for resiliency purposes becomes top of mind. Now, as we introduce latency, going across availability zones, we may only be dealing with like just a handful of milliseconds. As we start going across regions, as we start going across continents, we may then be looking at tens or 100 milliseconds or so of latency of round trip time that's introduced. And so this then, if we just naively took the same approach we used for, say, intra-AZ availability and tried to stretch it across continents, the latency in which we can operate suddenly reduces drastically, and then the customer experience of the application can be impacted. And so as we're designing and choosing the right solutions for each of these different levels of availability, we also need to be thinking of the other aspects, the other service level objectives that we're aiming to achieve as well. And so let's go and talk then a little bit more about that. So there's availability, there's latency, there's also cost as well that we need to bear in mind. Some of these solutions, as you can imagine, going from one server to 3 servers, we could potentially be putting in a lot more cost in terms of the infrastructure, the actual servers we're deploying and procuring. Also introduces some, potentially some additional operational overhead that we need to be thinking about as well. And so, understanding all of these and understanding how we can mitigate them or how they trade off against each other is really critical. So let's talk a little bit now about TiDB and how it can really help to address some of these issues and some of the options that it has available. So I'll give a quick overview of TiDB for those of you who aren't as familiar with it. But TiDB, it's an advanced open source distributed SQL database. So we're a transactional database that really suits the most demanding modern applications. So we have all of the things you would expect from a relational database, the transactional capabilities, online service, low latency, ACID compliance, and we're also a MySQL compatible database. So we enable you to move from kind of those traditional MySQL or MariaDB deployments to something like TiDB that would give you a lot more options for availability. It's also an open source project since 2015. Wide range of contributors, very popular, and a lot of adoption that we've seen out in our customer base and in the broader open source community. And what really makes TiDB, to my mind, one of the key capabilities it offers and why it's been so successful is its distributed and scalable and reliable nature. So it's really built-in replication, auto sharding, multi-master, and auto balancing. So all of these are capabilities that you get out of the box, and really things that you don't have to really think about that much operationally. It's something that just is a inherent attribute of the system as you deploy it. And it's scalable and deployable. We have customers who are achieving millions of QPS with a solution, and we have this ability as we distribute across, say, an availability zone, the ability as nodes go down, we can auto fail over, move that data across to other nodes and rebalance things to help keep you operational and help you to continue to satisfy your availability, latency, and throughput SLOs. And another key thing is that even with this distributed nature, we do provide strong consistency for your application. So, having to deal with weaker consistency is not something that you have to deal with TiDB when you're deploying it like this. It's something that comes out of the box. So again, this is an advanced open source distributed SQL database. And we'll talk a little bit about some of the options that it has in the architecture. So just so you understand the architecture a little bit, really there's 3 key components that we talk about here. First of all, we communicate via the MySQL protocol, and that comes into the TiDB cluster. And this is really the piece that's responsible for handling this inbound communication from MySQL. We also have the PD cluster and the storage cluster. So the TiDB layer, is this TiDB SQL layer, essentially enables us to separate the compute from the storage, which really simplifies the scaling and helps you to deploy TiDB in a truly cloud native approach, one where you're scaling the compute and the storage separately. Next, we have the PD cluster, or the placement driver layer. So this essentially is monitoring how data is distributed, and monitoring all of this and keeping things organized essentially for you. And then on the storage side, we have both row and column-based storage engines. So this the storage layer, TiKV and TiFlash, offers TiKV. It offers this built-in high availability and strong consistency that can scale to hundreds of nodes and a huge amount of data. And these components can be distributed, and the way that we deploy it on TiDB Cloud, and that many of our customers who are also deploying when they manage it themselves on AWS or GCP or Azure, they're deploying it into our cross availability zones and distributing it that way, so that TiKV, TiDB, and PD can really be deployed in a high availability fashion that's resilient to some of the issues we talked about earlier, like AZ level disasters and so on. And so as a quick overview of some of the options that TiDB have, the first one that just comes kind of out of the box is this concept of TiDB's high availability option, or I say not option, it's kind of inherent to the architecture. So the TiDB HA essentially helps you to be resilient to node failures, AZ failures, and so on. And this is really transparent to the application, and there's no operator interaction needed. If a TiKV node goes down, we can continue operating. There's no explicit operator interaction that's needed to fail over to another node or so on. That's all handled automatically. A next capability that comes out of the box with TiDB as well is what we call flashback. And so this is, whereas TiDB HA is really there around node failure or AZ failure, TiDB flashback is really helpful for what I call logical corruption, or let's say you drop a table or truncate a table by accident. Being able to flashback and move to the prior version is what this enables. And TiDB flashback operates within what we call the garbage collection window. So by default, this is usually set to 24 hours. And so you're able to essentially roll back or flashback the cluster to, or a specific table, say, to a specific point in time within that garbage collection window. And this flashback, it does depend a little bit on the amount of data, but it's usually just within a few minutes. And this is something that an operator would trigger. So I think for the rest of the talk is going to be a little bit more about disaster recovery, and this is where these two capabilities of TiDB backup and recovery and TiDB DR with TiCDC come into play. So backup and recovery, again, a capability that is available with TiDB. And this is, again, helps you with cluster failure, region failure. You're able to recover from backups, and also logical corruption. Comparing this with flashback is, of course, as you think about backups, you can have much longer period of retention for your backups compared to your flashback, which relies on data being within the garbage collection window. And so the backup gives you a lot of flexibility in restoring from those earlier points in time. RPO, with point-in-time recovery, that's an option with the TiDB backup, is it could potentially be seconds. So we do have this, point-in-time recovery. You can also just rely on periodic backup as well if you don't want to configure the point-in-time recovery, in which case your RPO would be hours. And recovery time objective can depend on the volume of data that you're restoring. It may just be a few minutes, but for very large volumes, you may be looking at multiple hours. And it's something that, of course, is managed by the operator as well. Now, talking about TiCDC, this is more of a replication solution. So this is something that is able to help you be resilient to cluster failures and so on. And again, the RPO in this case can be in seconds, and the recovery time objective can be much faster as well. The reason for this is because you're replicating data to a live database, and so the data is available there, being able to be served from that database. And this also requires operator interaction and looking at the orchestration of the failover of your application to use the replica database. Okay, so that's a quick run through of all of the options. What I'm going to talk now about is the ongoing testing and validation, the relative importance of that. And then I'm going to do a demo, and I'll be doing a demo of the TiCDC offering, the replication, and talking about how we can use that to periodically test your recoverability of data and just test that out. So one thing I've experienced or seen over time is that the likelihood of a successful recovery, really does decrease over time if it's left to what I say to atrophy. So you may be thinking, why is that the case? If I don't touch anything, is it just going to be the same? Well, for sure, like if you don't change things, then that may minimize some of the atrophy. But what we see in practice, or what I've seen in practice, is that that's never really the case. There's always application changes that need to be made, or if there's not application changes, there may be platform updates that are required. If you're deploying on, say, Kubernetes, on a managed Kubernetes instance from one of the cloud providers, you're going to have to periodically update that to keep up with the supported versions. Same if you're deploying onto Linux or Windows or so on. Those platform updates and patches need to be taken into account, and that introduces change to the system. Or even if you're not changing your application, you're not updating your platform, what doesn't change or what will change is your security exposure. The security issues that may come into place, new exploits and so on get released, and so even if you don't touch anything, just the process of time, things change. But what I've seen happen is that as changes occur, if you put a DR plan in place, maybe you tested it when you first deployed the application, if you don't look at it again and come back to it a year or 2 years later and try and rerun that plan, there's a very high likelihood of being some kind of issue with the recovery process that you'll hit, and that you'll need to then go in and figure out a workaround for. And this will increase your recovery time, your ability to meet your recovery time objective, which impacts your availability service level objective. And so, this likelihood of success does change over time. Now, one of the ways that we can alleviate that or really mitigate that is by testing frequently. So if we test our disaster recovery plans frequently, and then when we identify an issue, go ahead and remediate that and fix the DR plan, the DR process that we're executing, we can continually make sure that our likelihood of meeting our service level objectives is increased. So this is something that I saw in practice many times. I had the opportunity, many years ago, I went on site with a customer who was essentially doing a full-fledged DR test. This was something that they did every quarter, and they invited me along as kind of an observer and, to kind of see what they were doing and make any recommendations for improving their disaster recovery process. So I got to watch this kind of end to end. They did it over a weekend, and so I got to camp out in the office with them, which was kind of fun. We had a fun time. But what I always remember from this process is that there was one step where they were recovering their databases, and this was many years ago, before TiDB was even conceived. It was a SQL Server farm, actually, and they were doing the failover of the SQL Server instances. And as they were going through that process, there was one point where, this was several hours into the DR process, and this was a huge organization. A lot of systems they had to fail over as part of the testing. They got to a particular point where the commands that they were trying to execute from the DR plan just weren't working. And it was like, everyone was kind of confused about what was happening. And essentially, we kind of backtraced through the previous steps, trying to figure out what had gone wrong, why this particular step they were trying to do just wasn't working. And essentially, there was a typo in the DR plan that someone had essentially ran a script in a previous step that essentially didn't work the way that they expected it to. And so this meant that the subsequent step, this was, I think, like 45 minutes to an hour later after they'd made the original mistake, the subsequent step was failing. And so we had to go back and kind of redo all of this. And so the likelihood of going through any plan without any issue, if you're not testing it frequently, is very low. You need to be testing frequently because it will flesh out these issues that occur. It will, problems with scripts that you may have written, maybe a parameter's changed or you've updated a version and now, the script doesn't quite do what you're expecting. So continually testing and retesting on a periodic basis will help you to continue to meet your service level objectives. And my advice really is to use a range of validation and testing strategies. And so you can start off with simple things like plan reviews. Just really write down kind of your expectations, what you're expecting to do, and just review that. Have multiple people put eyes on it. Is it covering all of the systems you're expecting? Does it map to your applications? Is it going to satisfy the dependencies and things like that? That's all things to bear in mind. The next thing you can do is run tabletop exercises. Once you've got a plan, war game it, kind of go through it over a tabletop, see how it's working. The third step is plan testing. You actually go through and exercise the plans live, actually perform the failovers or test failovers and really raise the level of confidence that you have in your plan working and identify any issues with it so that you can remediate those issues. And then another thing I'd recommend as well is look at introducing some chaos engineering into the system as well. I have customers who are using when they deploy onto Kubernetes, using solutions like Chaos Mesh and so on to actually simulate issues at kind of a server level, component level, introduce different experiments and just really try and ensure that you're having a broad coverage of all of the different types of issues that you may be expecting and ensuring that you've got a mitigation or plan in place to deal with those and validating that. Okay. So with that, with plan reviews, tabletop exercises, plan testing and chaos engineering, let's talk a little bit more about plan testing. So this is the one that I'll do a demo of. So just to kind of walk through at a high level, what I'm going to do is really 4 steps. So we're going to start off with a scenario where we have a primary database replicated to another database. And the first thing we're going to do is for our testing, we're going to essentially temporarily separate those databases so that our primary system continues to be online, servicing our application. But we're going to use a replica for testing the DR plan and doing some operations in a DR test environment. So the first thing we're going to do to essentially pause the replication so that we can treat these two separately on for the duration of the testing. Next, we're going to run the validations on the replica TiDB cluster. In this example, it's going to be very basic. I'm going to just do a few minor changes just to simulate making some changes on the replica database and show that that doesn't impact the primary and that the ongoing changes to primary don't impact the testing either. So just a short example to test that. But in practice, this would be something that would be a little bit more involved during your testing. You may well be looking at spinning up an instance of the application to connect to the testing environment so that you can, or the DR testing environment, so you can validate the application and that failover portion. So next, we can actually, once we've performed the testing, we're going to leverage the flashback capability of TiDB to actually essentially reset the TiDB cluster at the replica site back to the state that it was when we paused the replication. So this is essentially going to ensure that the database, so we've got our primary that may have been changed. but the replica database here is going to be set back to the state that it was here when we first paused. And then once we've got it back to that original state, we're going to essentially resume the TiCDC replication, and it's going to pick up from where it left off when it was paused and replicate any subsequent changes on the primary side back over to the replica database. So that's a demo, and this will take, I think, like 5 or 6 minutes, just a short demo I recorded for you yesterday. So let's go and take a look at this. So I'm going to have two locations. The green screen is going to be my Oregon cluster, essentially. So I'm just connected there, and I've got it replicating over to Tokyo. So here in Oregon, the first thing that I'm going to do is essentially just show you a little bit about the change feed we have configured. We're just going to validate that, hey, we do have replication configured here, and we see I've got a single replication task. The state is replication task 1, and the state of that is normal. So we're happily replicating across the data. So now we're just going to connect to the database, and I just have like a table with some dummy data in here. Just select the 10 most recently hired people, and that's the state of the data. So let's switch over to Tokyo, and we're just going to validate that yes, we have that data over there as well. Let's paste that in, and yeah, you can see we have the same data that's been replicated across to Tokyo. So exactly the same. Okay, and then just to validate that the replication is working, we're going to insert another value here. So Ben Meadowcroft is going to join in the Sunnyvale HQ. So just select that, and you see, yep, I've been added, and we'll switch back over to Tokyo. And just check, yep, the replication, the data's been replicated across. So we're in a status where we have the two databases, replication is established between the two, everything looks good and healthy. Okay, so next we'll come out of the SQL interface, and what we're going to do is actually pause the replication now. So I can list here the replication task, and I'm going to pass in the replication ID, the change feed ID, replication task 1, and pause that replication. And if I list the task now, I can see that the state of that is stopped. Okay, so this was the first step that we talked about. By pausing the replication, we've essentially separated the two databases. If I make changes in on the Oregon side, that's not going to be replicated anymore. So now I'm going to make a change to simulate the testing. Here I'm just going to update my office location. So let me just tweak that there. So this is, you can imagine doing much more complex interactions with the test database. I'm just doing a fairly simple one here. Yeah, updated it. Now I'm in San Diego. And we're just going to go connect to MySQL again. And we can see that I'm still in Sunnyvale on the production side. So the changes in my test environment didn't impact my production environment. They're still, completely separated. So again, the testing here, I can do a lot more work on the testing. And also the other nice thing is I continue to operate on my production side without impacting the testing. So if I make any changes on production, like here, I'm going to insert a new employee, Jane Jones. See, they've been added. So now on my production side in Oregon, they've been added. But over here in Tokyo, I just select that. Again, the last one was my change. That Jane Jones hasn't been added here into the cluster. Okay, so we kind of shown we can make changes on the testing and on the primary environments now without them impacting each other for the duration of the test. So, once we've validated that, we need to now think about, okay, the testing is completed. I want to make sure I can reestablish replication and get things back up and running, reestablish the replication environment between the two. So the first thing we do then is this flashback. So a little typo there, but now I need to flashing back the cluster to what's called the TSO. So this is an identifier for the transaction. So we can take the TSO here, which is reported from the pause replication task, and put it here. So now I'm going to flash back my entire cluster to this earlier transaction. Okay, so I flashed it back. This should have reset it back. So now Ben Meadowcroft should be in Sunnyvale, not in San Diego. So let's check that out. And yep, I can see, yeah, I'm back in Sunnyvale. Okay, so we've got the test cluster or the secondary cluster now back to the earlier point in time. But we have data that's on the Oregon site that hasn't been replicated across. So our production, during this testing hasn't been interrupted. It's been able to continue servicing, the application. So what I'm going to do now is resume the replication. So this is very straightforward. I can just ask TiCDC to resume the replication. And again, straightforward, execute that. And what this will do, it will pick up from where the replication was paused and bring across the rest of the data to the secondary site. And you can see that the replication status now is normal, not paused. And if I go back over to Tokyo and select from this, I can see that that value Jane Jones that was added in on the Oregon location has now been replicated across to Tokyo. Awesome. So just to kind of recap the demo or kind of this process, essentially we start off with a replicated cluster. The first thing we do is we pause a replication so that we can have an opportunity to so that we have the opportunity to separate the two clusters from each other without them impacting each other. And so I can make changes during my testing period on either the production or the testing side, and they don't impact each other. So I can continue to protect on my primary site while I'm testing on this replica copy of the data, making changes to that. Really validating that, say, my application that's failed over can continue to operate against that database. And then after I've performed that testing, I can essentially flash back the replica TiDB cluster back to that earlier point in time. So the point in time, and you saw when I selected from the list of replications, it included the TSO value. So I can flash back the cluster to that earlier TSO value at the point where I pause replication. And then finally, I can go ahead and resume the replication. And essentially this will catch back up and make sure that my replica data now matches what was in my primary database using the asynchronous replication of TiCDC. Okay, and then what we've covered today was really three things. Just a quick overview of understanding your risk exposure, how important it is to understand the types of risks that you're exposed to, the probability, and then the impact of those. And what I hope you got from that was the importance of that impact is really tied to how does it impact your service level objectives. And then as we think about designing for availability and recovery, when we look at the risk exposure that we have and we want to mitigate that, that will reduce the impact on our SLOs, on the availability SLO, but we also need to be considerate of how that may impact, say, our latency SLOs, for example, and make sure that we're choosing the right level of capability or the right capability to meet the needs that we have in our that we're designing for. And then finally, talked a little bit about ongoing testing and validation and the importance of that in reducing your overall level of risk. And then a short demo of actually how we can say, take one of those capabilities, TiCDC, and how we could actually, leverage that to enable you to do non-disruptive testing. So hopefully, that was useful for you. We're happy to take Q&A. I think Brian will help moderate that. And then finally, if you're interested in having a free demo, please, take a look at the QR code before. Please scan that. and be able to request a free demo there. But thank you so much, everyone, for your attention today. I hope it was helpful for you, and happy to take questions.
Excellent. Well, thanks, Ben, for the excellent presentation and of course the demo of TiDB's disaster recovery capabilities. Let's see if we have some questions from our audience. Looks like we have a few. Let me start with one here. So, question from one attendee. Does it mean TiCDC supports two-way or multi-way replication with certain auto conflict resolution rules? Or does it just allow, for example, the Tokyo one to serve production traffic during a disaster, but then it eventually has to roll back any local changes and catch up with the Oregon one?
Yeah, sure. That's a great question. So essentially, TiCDC does provide you a lot of flexibility in the topologies that you want to support. So certainly, you can configure TiCDC bidirectionally between, say, Tokyo and Oregon, or an Oregon and Tokyo. We do have some bidirectional capabilities. However, what I would say is that it doesn't do auto conflict resolution for conflicting rows. Essentially, the way that our customers leverage this is essentially certain rows are owned by certain clusters during normal operations, and so you may well have certain tables owned by certain clusters or rows owned by certain clusters from an application level. And so the conflict resolution would generally be handled at the app level rather than at the DB level for that. And then we also have introducing some new capabilities around, support for bidirectional DDL replication, which you can see a little bit more about in our documentation. There's certain DDLs that we'll be able to support the replication of across the asynchronous replication. So there's some more improvements on that. But yeah, we have customers that use TiCDC. It doesn't just have to be two locations. You can have one cluster replicating to multiple clusters and things like that. Those clusters can be serving read traffic and things as well if you want to distribute the load. Or if you're segregating out the row or table level, you can also be serving writes from those areas too, but that's at the application level.
Excellent. No, it's a great answer. Here's another one that we have that came in. What is the recommended GC lifetime setting? There's some additional commentary here. Default is 10 minutes, but it seems a bit low for a flashback feature. But on the other hand, large GC values means a performance hit when using TTL feature when the workload is write heavy.
Yeah, no, that's a great question, and that's something that will vary by customer need for sure. But certainly, if you're looking to use a flashback feature, say for the testing, that's something that you can also configure during the test period. So you can update the garbage collection for that duration. Particularly, and this will be at the replica site, which is where you'd be doing the flashback. So that is something that if you want to manage that if you don't want to just increase it overall, for default, it's something that you could tweak, prior to performing the testing at the replica location.
Excellent. No, that was a great question. I have just a couple more here. It looks like we have some time. Let me get to those. What are some of the constraints of the flashback feature?
Yeah, I think that was one of the main ones that came up in the prior question. Actually, was the GC limitation. It does rely on the garbage collection capability, and so the duration of your test period, you would want to ensure that your GC is sufficient during the testing to support that. So that's kind of one of the main ones.
Excellent.
And there are a few other detailed limitations as well in the documentation that we can maybe share a link to whoever set up.
That'd be great. No, thank you for that. And just one more final question here, at least that I can see so far. Can you explain some more about the trade-offs between TiDB's backup and recovery feature and using TiCDC for disaster recovery?
Yeah, sure. No, I think this is a great question. Probably I would say there's kind of functional trade-offs, and then there's also cost trade-offs as well. So if you think about the backup and recovery, essentially what you're doing, you're backing up your database essentially to a storage target, whether that's object storage or storage server with NFS or something like that. So essentially the backup of the database is going to that external storage. And then when you're restoring it, that data essentially has to be read back in and essentially applied to the TiDB cluster. And so that period of time, depending on the volume of data that just needs to be read and applied, could be a significant amount of time. So if it's a large amount of data, that could be a few hours that it takes to bring that back. But the trade-off of that, or the benefit of that, is because it's going to an object storage location, say, that can be a relatively cheap storage target that the data is being stored on. So you can store it there, you can replicate it to another object storage location, and so you're able to achieve the ability to say, hey, you know what, if I've got an AZ that's down or whatever, or a region, say, that's impacted, I can maybe recover from the backup into another location and spin up the resources as I need them in that location. And because the compute, because we're not running a compute or resources and database, the full time, we're just the majority of the time you're just using the storage cost, then your overall cost of ownership is going to be lower. But the trade-off is that your recovery time objective, if it's within the hours, great. But if you've got like an RTO that's within minutes, say, or much shorter, then restoring from backup is not going to enable you to satisfy that time objective. So depending on the application, depending how quickly it needs to be brought back up and functional, is the main trade-off. TiCDC, on the other hand, because it's a replication solution, you have the TiDB cluster deployed at both locations. And so the data is being replicated across continually. And you saw just in the demo where you apply it on one site, it's replicated across, and you can query it at the other location. It's being served live. And so switching over your application then to point to that replica copy or treat that as a primary is really more a function of how quickly your application can perform that failover and be repointed to that location. And so you're able to achieve much more aggressive recovery time objectives. But of course, you're running a TiDB cluster the whole time to receive the replications that are coming in. And so the costs are a little bit higher than just having stored, cheap and deep object storage. But it enables you to meet those recovery time objectives that are a little bit more aggressive.
Gotcha. Excellent. No, that was a great answer. All right, let's see. I know we're getting closer to time. Let's see if we have any other questions from attendees. All right, it looks like we have another one. Kind of talked about this a little bit, but here's a question. Could you talk about how backup restore works and the cost structure of the snapshot and backup? To share the context, we're on AWS, and the snapshot plus backup is a majority of the RDS cost.
Mm-hmm. Yeah, so I think as I mentioned, the way that backup, let's say you're deploying onto AWS TiDB across a single region, so across 3 AZs, single region. That's probably the most typical deployment that we have, just for a cluster on a single cluster on AWS. The backup function, essentially what it's doing, and there's two options for backup. We will do a periodic backup of the full database, and then you also have the option to configure point-in-time recovery that enables you to essentially we back up the changes as they're occurring and enable you to do much more fine-grained recovery. So rather than backing up from, say, like 24 hours ago or 12 hours ago, you can do a recovery from just a minute ago, say, or and you have much more fine-grained selection of like, hey, you know what, I want to recover from this specific point in time, roughly 6 hours ago, and be very specific on the time frame. So in terms of the costing, essentially that data then is being essentially stored out onto S3 and persisted there for retention. So the cost that we have is really just the cost of sending that data to S3 and storing it in S3. The cost will vary a lot depending on the retention period that you're looking to have. So of course, the longer that you're retaining the data, then the more costly it is going to be, because we have to keep that data around and it incurs a cost. And yeah, so it's a pretty straightforward in terms of figuring out the costing there. Same with the log back, the point in time recovery logs that we'll be storing. That again also goes to the object storage. So it's really just that sending the data across and storing it depending on your retention period. I mean, certainly, what I would recommend if you're interested in kind of pricing it out a little bit more or trying to understand it, our field is always, happy to kind of help answer those questions. Also, our TiDB Cloud offering as well, like TiDB Cloud Serverless is a great option for a lot of customers and it does come with the backup capabilities kind of out of the box by default for that offering. And so, that serverless option is a great option, for being able to, get the level of backup that you need to support the workload without having to worry about, additional costing and so on beyond serverless cost.
Excellent. Okay. Taking a look here, looks like we've gotten through all the questions, and I know we're getting close to the time, so I think it's a good time to wrap up. So thank you everyone, for attending today's talk. Thank you again, Ben, for the excellent presentation walkthrough. We'll be sure to make a recording available to everyone who registered for the event in the coming days. So look forward to that. And again, as seen in the slide, if you'd like to learn more about TiDB's disaster recovery capabilities in action, please feel free. You can request a demo, pingcap.com/demo. And with that, like I said, I would like to wrap it up and thank you all. Have a great rest of your day.